Hi everyone. In this tutorial I'm going to show you how to use Harmony.AI's Quickstart repository to run all services needed to control AI characters locally on your machine. First thing you need to do is to make sure that you have Docker running on your machine. If you're using Windows, the easiest way to install it is to install Docker Desktop. Next up, navigate to our Quickstart repository on GitHub and clone it using the Git command line interface or download it as a zip file. The Quickstart repo is pre-configured to provide you with Docker images of Harmony Link, Harmony Speech Engine, and a Harmony.AI variant of text generation web UI. Latest versions of our Docker images are always provided via Docker Hub and are regularly being updated. By default, our Quickstart repository provides you with a standardized setup for running AI models either on CPU only or using recent NVIDIA devices. A setup for recent AMD devices will also be provided at a later point. So, now, before we start looking into customizing the configuration, let's quickly evaluate the system requirements for the different components. If you have a CUDA-capable graphics card with at least 4 GB of video RAM and a CPU with at least 4 cores, you're already good to go for a majority of configurations. Of course, the more video RAM you have and the more powerful your graphics card in your system are in general, the better your experience will be. In case you want to use a CPU-only setup, you should ensure that your CPU is a little more recent and powerful and that your machine has at least 16 GB of RAM or more available for a good experience. The Harmony Link container, which can replace the manually executed instance of Harmony Link, needs about 200 MB in RAM, and both the speech engine and the text generation web UI need about half a gigabyte. Keep in mind that if you're running a CPU-only setup, you'll need to also load the model weights into your RAM. Also, to be able to download all the Docker images and AI model weights, we recommend to have at least 50 GB of free disk space available to use the local AI setup. For the models related to Harmony Speech, we also provided a table with the available models and memory requirements on the Quickstart README page. However, for large language models used by TextScan, the memory requirements highly depend on the model you are going to use and the quantization bit size, so please check that separately. So that's that. Now let's continue with our local setup. Important thing to notice is that the Harmony Link container is currently not able to expose its configuration UI. So in case you want to use the container at the moment, you would still have to use the local instance of Harmony Link to make a configuration file, a config.json, and place it into the Quickstart repo's Harmony Link folder. If you then start your local setup using the docker compose command, Harmony Link will start in a container and will use that configuration. To do this, you can just quickly navigate to the folder where you placed your Harmony Link binary, copy over the config.json and place it inside of this Harmony Link folder of the Quickstart repo. Okay, now let's take a closer look at the two core files of this Quickstart setup. It's those two files, dockercompose.yml and dockercompose.nvidia.yml. People already familiar with Docker will likely be used to working with these, but let me explain what they do and how you can customize them for your needs. One important notice though, before you start modifying these files. YML files, or just YAML, are so-called markup language files, and they are highly sensitive to the indent at the beginning of a line, for example here or here. Similar to Python, YAML uses line indents to differentiate between different values and elements which belong together. As you can see also at the top here, this file defines services without indents, and then all three Harmony services, one after another, each of those with exactly one line indent. And everything that is relevant to one specific service has even more indents. Therefore, I also recommend to not use a default text editor for modifying these, but a code editor like Atom, which I'm using here right now, that can handle line indents natively. A link for downloading it is provided in the video description. Another useful function provided by a code editor when working with these kind of files is that they allow us to select and disable multiple lines at once, which is commonly also called commenting out and commenting in lines. In this example, I select multiple lines of a single service, Harmony Link in that case, and comment it out. This means if this file is being used by Docker, it won't start that service. And of course, I can also perform this with single lines, for example to disable the pull policy, an automated check for a new version of the Docker image on startup. In Atom, I can toggle commenting in and out by pressing both the Ctrl and the hash key where lines are selected. Let's give you a quick example. I'm changing this editor from full screen to windowed mode now, and then I use the Windows Explorer window to create a new command window for me. If you click into the location bar in Explorer, you can enter cmd.exe and Windows will provide you with a new command window which has its working directory pointed at the specific folder you entered that command into. Also, I opened the Docker Desktop UI. Now, if I switch back to the command window, enter docker compose up, and confirm the command with the enter key, Docker will start downloading all the image components required for the services, which are defined in Docker Compose YML, which can take some time, however, depending on the internet connection. As soon as everything has been downloaded, the CMD window will switch to a monitoring view and show you the log output of all components which are running now as part of the compose command. In the Docker Desktop window, you can now also see the active images, and if you click on the setup, you can also see the output there. Harmony Speech Engine will immediately start downloading all model weights required for its current configuration and load them into memory. Also, before using the local setup, please make sure that all containers confirm that the API endpoint is up and running with a log line showing host IP and port. Getting back to what I actually wanted to show you, we'll disable the local setup again by focusing the command window and pressing the keys Ctrl and C at the same time. Docker Desktop will get an interrupt signal and shut down the containers. Alternatively, you can also use the stop button in the Docker Desktop UI for this action. To ensure full cleanup after the shutdown, we can now also enter Docker Compose down and hit enter in the console, which will clean up the whole Docker setup completely. Now, I'll quickly switch back to the Docker Compose YAML file and comment out the service definitions for Harmony Link and Harmony Speech UI, since we don't need them right now. I save the file, and in the command window again, I enter Docker Compose up. Now, I'll only see two containers starting, Harmony Speech Engine and TextScan Web UI. And that was the main part already. Everything you need to get Harmony.AI running locally with using only your CPU and enabling or disabling individual services. But what to do in case you want to use your GPU completely or partially for running some of those services? It's pretty simple. The only thing you need to do is specify the compose file for NVIDIA in the Docker Compose command directly instead. The machine I'm currently using has a graphics card of type NVIDIA RTX 3060 with 12 GB of video RAM installed. This should suffice for loading all model types of Harmony Speech Engine by default. Yep, and there we go. All basic models for text-to-speech and speech-to-text have been loaded, and the card still has about 6 GB of VRAM available, which we can now use to load an LLM into TextGen. Just one more thing regarding Harmony Speech Engine before we do that. Since there's a wide variety of setting and model combinations you can use for Harmony Speech Engine, you'll also find two more YAML files here in the Harmony Speech Engine folder, which you can modify to change the models used by the speech engine container and how it will be setting them up. However, going into these details right now would be significantly out of scope for this setup guide. In case you want to look into that, there's an extensive documentation about all that inside the Harmony Speech Engine GitHub repository documentation, and it's also referenced in the README for this local Quickstart repository as well. Feel free to check it out. Staying in the browser here, we check with the Docker Desktop UI that our TextScan container is still up and running, and we copy the URL for the web interface from the console into our address bar. Be aware that web servers inside containers will usually show the URL where they are serving their stuff. To actually access it via the browser, you'll need to use your localhost address or IP 127.0.0.1 instead. Once you fix that up, you should see the web UI in your browser. If we switch to the Model tab, we'll make the unfortunate discovery that we didn't download a model yet. So what we need to do first is to go to Hugging Face and find one. For this example, I'll be picking the Hermes 2 Pro fine-tune of Llama 3 with 8 billion parameters in the GGUF format. Once the model downloaded successfully, we can refresh the model selection and pick the model. TextGen will automatically detect that it's a GGUF model and will switch to Llama CPP mode. Depending on your GPU, you'll probably want to limit the context size for the model and also the layers sent to the GPU to avoid out-of-memory issues. In case you run into them, try to use less layers. Once the model was successfully loaded into memory, you'll be able to see this inside the UI and also the Docker logs for the container. The only thing left to do now is to start Harmony Link and make it use the local setup. We'll use the Harmony Link with the settings we configured earlier in the basic Harmony Link tutorial. So now navigate to your Harmony Link binary, start it up and select the CardG entity. Switch to the text-to-speech module and change the URL to use the localhost IP 127.0.0.1 with port 12.0.80. Once you click outside of the input field, the client should refresh and should show you all the models and features available in your local setup. Now switch to the user entity and do the same with the user speech-to-text module. Also here, you'll see the large model pre-selected for transcription and the smaller one for VAD. Finally, switch back to the KG entity and select the count and nouns module. This module uses the LLM backend to evaluate emotional behavior and also facial expressions for the AI characters. Change this one to the same localized IP as before, but this time with port 5000. You can, by the way, also use this TextGen endpoint for handling the conversations with your character instead of a cloud backend. All you need to do for that is to switch to the LLM engine module, select the text generation web UI provider, and use the same endpoint here. A check for verification, if everything is correct set up with those endpoints, will be added in the config UI soon as well. Finally, don't forget to save your changes. Now, the next time you'll be using a Harmony plugin to connect to Harmony Link, it will be using your local Docker setup. We hope this tutorial was helpful to guide you through the basics of setting up your local AI environment for Harmony Link. With future releases, we'll try to make the setup even more straightforward, but we also think, compared to earlier versions, that this is already a major improvement and a big step towards democratizing our software to make it usable by everyone privately. As always, thank you for watching, and be glad to see you over here in our Discord server, and if you think this project is useful, please consider supporting us via Patreon. Thank you very much, and goodbye.